In this video, I'm going to do 1, 2, and 3 MCQ, right? This is based on relation functions, class 11. So what is the first question here? The first question is this, that is the domain of this function. So if I see the function, this is fx is equal to x square over x plus 3. So what do you know that when the function is in the form of p by q, and what is domain? First of all, domain are those values of x for which the function is defined. As you can see that x square can take any values in the numerator, but over here, x cannot take, this should not be 0, right? The denominator, as you know that p by q form, where q should not be 0. So x cannot be -3. So except for -3, it can take all real values. So if I look into the correct option over here, except for -3. So this is the correct option in this case. Now we have done the first part. Let's focus on the second part. And what is that second over here? It says what is the range of this function? So the function here is what? This is fx is equal to x square plus 1. Range is what? The output, right? So let's begin with writing this as what x square implies here. You know that square of any number can be either 0 or greater than equal to 0. As you know, -2 square is also 4. That means square of all real number is either 0 or greater than equal to 0. But then we need x square plus 5. So what I'll do, I'll be adding 5 to both sides. So it results on giving what? This. Right? Adding 5 to 0 is, or 0 to 5 is 5. I can replace this. You can see I can replace this with fx. So we got fx, and fx is the output, right? Fx here is greater than equal to 5. So you can see that it can take any values greater than equal to 5. So 5 inclusive to infinity. And the correct option over here, this is a printing error. This is 5 to infinity. I think this, yeah, because no. Wait, this is, we need to include 5 also. So therefore, this would be the correct option. That is option C here. Now let's see the third one over here. So if I clean the board before doing the third. So in the third question, what is it? It's a greatest integer function, right? It's a greatest integer function. Let's see, this is box x, right? Not modulus x. So greatest integer function, the range we have to find out. So let's say if I tell you fx is equal to box x, that's the greatest integer. What you know that if I plug in any value, let's say if I place 2.3, then the greatest integer is what? 2. If I take 2.9 or say 3.9, so 3.9 is what? So how do we do actually? We think of a number line, then we look for 3.9, and we look for all integer preceding them, like preceding them is 3, 2, 1, 0. And among them, whichever is the greatest is greatest integer function. Similarly, if I take -3.9, so if you look into the number line -3.9, for example, preceding to this is what? -4, and then -5, and like this. So among these integers, whatever is the greatest integer function. So it's going to be -4. So even if you proved a fraction, decimal, or even an integer, the greatest integer of 5 is 5. So what you know that your output, that is the range, you see in every case we are getting an integer, whatever may be the input, right? The output is always an integer and not a positive, right? It can be negative or positive. So I can see that, where is that? Z is implied for integer. So C is the correct answer in this case. In this question, we have to find the range of this function here. So what is the general method for finding the range? We put fx as y, right? So we'll do like this only. Like if I put y, fx as y, what do we get? 2x plus 1 over 3x plus 2. Next, we'll do cross multiplication to write x, y in terms of x. So it's going to be 3xy. Then x multiplied with 2 is what? Sorry, y multiplied by 2 is 2y, and then 2x plus 1. Keeping x variables on the one side, left hand side, on the other side it's 1 minus 2y. Further, I can take x common from here. As I said, I'm going to write x in terms of y. So it's going to be 3y minus 2 is equal to 1 minus 2y. Now finally, x can be written as x is equal to 1 minus 2y over 3y, right? This is 3y minus 2. So you can figure out that is in the form of p by q. And what do we know that here, this cannot be 0, right? As you know that a function to be defined, here y cannot be 0. So if y cannot be 0, that means y should not be equal to 2 over 3. So I can see that y can take any values except for 2 over 3. So r minus 2 over 3. Like, yeah, this is what r minus 2 over 3. That's the range of this question. In the fifth question, it says domain of this domain of the real valued function. So this is what fx is equal to. What do we know that for a function to be defined, in this case, this should not be 0. That means it's in the form of p by q. So we can say from here that for the function to be defined, that is, what's this? X square minus is plus 6x, right? X square plus 6x plus 8 should not be equal to 0. In that case, what should x be not 0? So I'm going to factorize this. I can write 6x in the factors of 8. So it's 4x plus 2x plus 8. So it's easy to figure out what I did here. I wrote this 6x as 2x plus 4x plus 2x. Now what is common here? First two term, x is common, so it's x plus 4. If I take 2 common, this is not equal to 0. I'll again get x plus 4 not equal to 0. Now further solving this, taking x plus 4 as common, we get x plus 2 as the other factor. These two factors should not be 0. That means x, equating this with not equal to 0, x cannot be minus 4. And from here we'll get x cannot be minus 2. So say that r, the here all real number except for these two, that is minus 4 and minus 2. Well, when I look into the option over here, there isn't, right? So that means there could be a printing here. We'll say that this is the correct answer. We'll do MCQ 6 and MCQ 7 over here. Now, first MCQ, that is MCQ 6 here, as you can see that the number of elements in A is this, a number of elements. In fact, the elements are given, but why did I say number of elements? Because we have to find the total number of relation from N of A, from A to B. So first of all, what we know that the number of element in A cross B will be equal to number of elements in A, which is 2, multiplied by the number of elements in B, which is 2 again. So you'll find that the number of elements is how much? 4. But then we have to find out the number of relation, which you know, it is a subset of A cross B. So the required number will be 2 raised to the power m into n, that is 4 in this case. 2 raised to the power n of A cross B. So 2 raised to the power 4 is how much? It should give you 16. So I can see C is the correct option in this case. Now check for the next one. Here fx is given as this, and we have to find f2 plus f minus 1. Very simple. First we'll get f2. That means replacing x with, wherever there is x, with 2. So it's going to be 2 square minus 2 times x, which is 2 times 2 here, minus 3. So 2 square is what? 4 minus 4 minus 3. This get cancelled and we get this as minus 3. Now similarly, I'm going to get f minus 1. This time I'll be replacing x with minus 1. So it's going to be minus 1 square minus 2 times minus 1 and minus 3. So check here, minus 1 square is what? Positive 1. Product of these two will give you positive 2 and this is negative 3. So here it is what? I'm getting this as 3 and this is minus 3. So it comes out to be 0. Now check here, if I plug in the value here, we have to get this f2 which we got as minus 3 and f minus 1 we got as 1. So the result is how much? This is minus 3 plus 0. Sorry, this is minus 3 plus 0. We got this 0, right? So it's coming as minus 3. Therefore, B is the correct option in this case. The next question is, it says f from R to R. R stands for the real number. Given by fx as fx is equal to x cube plus 3, then the pre-image of 39. So what is pre-image? Let's say, for example, if I just give you a small idea about this, let's say I make few elements here, right? Let's say these are some elements, and these are some elements on the second set. So when we make an arrow diagram during this, so therefore, if I say that, assume this being the image, right, of this element, right? So if I say that A is the image of B, then B should be considered as the pre-image, and pre-image is from the domain, right? So it's from the X. So if I write down this function once again, the function is what? Fx is equal to x square plus 3. So 39, the pre-image of 39. So I'll replace fx with 39 and obtain x. That's the rule. One more time, to obtain the pre-image, we replace fx with whatever the number given whose pre-image is to find out. Now from here it's simple. If I transpose 3 to the left hand side, 39 minus 3, which is 36, is equal to x square. So x is what? Plus minus 6. Plus minus 6, yes, here is an option. So C is the correct option in this case. In question 14, it says range of the relation R defined by R is equal to A, comma, A plus 5, and these are the values of A. So let's say obtain the range. In fact, I'll obtain the ordered pair here, replacing A with 0, what I'm getting 0. Over here also 0, 5 is what we are getting 0, 5. The second ordered pair will be what? Replacing A with 1 here, right? I'm going to replace A with 1. So replacing A with 1 over here, it's coming as 1, 6. Same way I'll go for 2. So it's 2, 7, and 3. 3 should give you how much? 3, 8. Yeah. And 4. 4 is what? 4 plus 5, that is 9. And then 5. So it should give you what? 5 plus 5 is 10. Now check here. What you need to remember that here these are the values of A and not A plus 5, right? A plus 5 can take any other values. As you can see that here only they are saying that A belongs to this. So when we plug in A as 0, 1, 2, 3, 4, and 5, what we are getting? A plus 5, which is the range here, right? So range is what? A set here. So it comprises of 5, 6, 7, 8, 9, and 10. So the answer for this is range is this. In question number 13 is given that if 2a plus b comma a minus b is equal to 6, 3, then we have to get this. So this is clearly an ordered pair. As you know that the first element of this ordered pair, right, will be equated with 6. Two ordered pair are equal only and only if the first element, their corresponding elements are equal. So I can equate 2a plus b with what? Equals 6, and a minus b with 3. Now what I'll do, I'll use elimination. If I add these two equations, 2a plus a is what? 3a. And this side 6 plus 3 is 9. That means a will be equal to 9 divided by 3 is 3. So we got the value of a. Now I can replace a in any of this equation. Let's say if I replace in first equation, replacing second here, right? Replacing a with 3. So this is 3 minus b is equal to 3. That means b is equal to how much? 6, right? Is it 6? Yeah. No, it's coming 0. Let me show it again. Minus b is equal to 3 minus 3. So it's minus b is equal to 0. So b is equal to 0. So that should be the value of b in this case. In the 12th question, it says P is what? P is a set X such that X is less than 3 where X belongs to natural number, and Q is X such that X is less than equal to 2 where X belongs to whole number. Then what we have to get is P union Q cross, right? P intersection Q. So let's figure out what is this set P comprises of. So these comprises of, it should be natural number but less than 3. So what are the natural number less than 3? It is 1 and 2 only, because natural number starts from what? Natural number starts from 1. And Q is what? Q here is a whole number, but has to be less than equal to 2. So it will include 2, and whole number starts with 0, right? So that's why it's 0, 1, 2. Now check here, we have to first get P union Q. So P union Q will be a set comprising the union of this, which is, I can clearly see it's 0, 1, and 2. And P intersection Q, this is what we have to get. So the common elements of P and Q, and this is 1 and 2. Now check what we have to get. We have to get their Cartesian product. So that means this cross this. It's important to understand that we have to get P union Q, right, cross P intersection Q, right? Their reverse is not true. So I'll do like 0, 1. You can see from the ordered pair, 0 can be clubbed with 1, 0 can be paired with 2. Likewise from here, 1 can be paired with 1, 1 can be paired with 2, then 2 with 1, and 2 with 1, and 2 with 2. So 2 with 1 and 2 with 2. Yeah. So let me check again. 0, 1, 0, 2, 1, 1, 1, 2, and 2, 1, 2, 2, 2, 2. So this will be the answer for this question. In the next question, it says if the ordered pair A minus 1 and 5B belongs to this relation y is equal to 2x minus 3, then the values of A and B. So as you can see that this ordered pair will satisfy this relation. So that means replacing x with 2, right? It should be x replaced, as you know, in ordered pair. Here x is the first element of the ordered pair. So if I replace x with a and y with minus 1, what we'll get? Y is equal to 2 times a minus 3. So minus 3, if you bring on the left hand side, is minus 1 plus 3 is equal to 2a. That implies this is how much? This is 2 is equal to 2a, means a is equal to 1. So we got the value of a as 1. Now in the next part, we are going to replace a and b with, not a and b, x and y with 5 and b. So first is replacing y with b, and this is 3 times x, and x should be replaced with 5 in the ordered pair. As you know, it's 5. So it's y is equal to 2 times, sorry, it's 2 times, right? It is 2. So b is equal to 5 into 3, that is 10 minus 3. So b comes out to be how much? 7. So this is what the value of b here as 7, and a, it will go towards, yeah, it will come like this. Right. So this is how it can be done.